Here is BIO1401 2019 final exam. Question number 1. Identify the force statement. And for the question is we want to identify what is force. So let's look at the options. Option 1, the 3s orbital is the lowest energy orbital in the similar energy shell. So when you look at orbitals, I just did this in chemistry. What orbitals do we have? So we are going to have 1s, then we are going to have 2s and 2p. For the p, we have got 2px, 2py, and 2pz. And then we are going to have 3s, 3p, 3d. We are going to have 4s, 4p, 4d, also 4f. So there is f there. 5 will end at d. So option 1 is saying the 3s orbital is the lower energy orbital in the similar energy levels. If you look at this energy level, this one, the third energy level, 3s is the lower energy level. How do you determine the energy level of an orbital? When you are filling orbitals, you fill them like this. You start with the 1s, and then you come and fill the 2s. After the 2s, you fill the 2p, and then the 3s. After 3s, you fill the 3p and then 4s. After 4s, you fill the 3d and then 4p. So the one you fill first has lower energy. So you fill 3s before 3p and before 3d. So it has the lower energy. So this option is correct. It's not false. 2p orbital is higher in energy than 2s. This is also true. 2p is higher in energy because we fill 2p after we filled 2s. Okay. And then there are three 2p orbitals in the second shell. This is true. I've said for the 2p, I've got 2px, 2py, and 2pz. There are three 3s orbitals in the third energy level. Now, s is only one. It doesn't matter whether it is 1s, 2s, 3s, 4s, it's only one. So this statement can be true. The 1s orbital does not belong to the second shell. This is true. Just the word one means that it belongs to the first shell. So it does not belong to the second shell. So you can see the answer there. Be free to ask for any question that you not understand. Question number 2. The valence electron of representative elements are. Now valence electrons are electrons in the outermost shell. So it's 4 located in the outermost shell. That's what we call valence electrons. Number 3, identify the statement that is not correct. Not correct. For a hydrogen atom, the energy of the 2p orbital is lower than the 2p. Sorry, for an hydrogen atom, energy of the 2s orbital is lower than the 2p atomic orbital. This is correct as we've just said from the previous one. For a carbon atom, the energies of the 2s and 2p atomic orbitals are different. This is true. 2s and 2p, they can't be true. It doesn't matter the atom. 2s is always smaller than 2p. For an oxygen atom, the energy of the 1s atomic orbital is lower than that of the 2p orbital. Okay? The energy of a 1s is lower than that of a 2p. This is true. 1 is supposed to be smaller than 2. Okay? And then question 4, option 4, sorry. For any atom, 3 2p atomic orbitals are degenerate. This is also true. If you remember from chemistry, I said that the 2p or the p orbitals are like this. There are 3 of them. We draw them together like this. They have got the same energy. That's the meaning of degenerate. An atom with more than 2 electrons must use a higher energy orbitals. This is not true. Okay, an atom with more than 2 electrons must use higher energy orbitals. You can even use the lower energy orbitals as long as they can get to fit in that orbital. So that is the answer there. Number 4, the lone pair. How come there are a lot of people joining the class? Are you all guys registered for biology? The lone pair of electrons in water are in the. I'll allow you for today so that I don't disturb you. The lone pair of electrons in water are in the. Now you know water is like this. And you have got lone pair of electrons like that. Where do you find the lone pairs in water? So how do you find the lone where the lone pairs are going to be? You look at oxygen. Oxygen has got how many electrons? Oxygen has got, and I'm interested, okay, let me just get all of them. It has got a proton number of 8. So the electron is 2, 6. This is the first shell. So these 2 electrons will be in the 1s orbital. And then the second shell, these 6 electrons, 2 of them will be in the 2s, and then 4 of them will be in the 2p. Actually, the lone pairs will be in the 2p orbital. Okay, so that is the one there. Phosphorus has an atomic number of 15. Therefore, its valency is, you can write the electron configuration 2, 8, 5. The outermost, these are known as the valence electrons, so you have got 5 valence electrons. An atom of sodium with an atomic number of 11 and a mass number of 23 has protons, electrons, and dash. So how many protons, electrons, and neutrons are there? So since the mass number is 11, atomic number is 11. The mass number is 23, the atomic number is 11. So atomic number is also known as a proton number. So the number of protons is 11. For a neutral atom, the number of protons and the number of electrons are the same. So electrons also be 11. But neutrons, to find the neutrons, you remove the proton number from the mass number. So 23 minus 11, that is going to give us 12. So proton is supposed to be 11, electron 11, neutron 12. So 11, 11, 12. So the answer is 3. Number 7. The third shell with 9 orbitals can hold up to dash electrons. The third shell with 9 orbitals can hold up to dash electrons. So this question, if you don't understand it well, you'll not be able to, to answer it. Let's talk about, here we're talking about the third shell. So in the third shell, n is equal to 3, and we've been told with 9 orbitals. How many orbitals? 9. Each orbital can hold 2 electrons, and you have got 9 of them. 2 times 9 is 18. That's the one. Or you can say number of electrons that can be held by a shell is given by 2n squared. So you say 2, n here is 3, squared. That will give you 18 still. The character of p orbitals which determine the character of atom is, the character of p orbitals which determine the character of atom is directional, non-directional, horizontal, vertical, diagonal. Okay, This question is trick. Character of p orbitals, which determine the character of an atom. So let me first make us understand how a p orbital is. Let me maybe ask how anyone who can answer, how does a p orbital look like? A p orbital. Anyone? You guys. So yes, please. Okay, good. So the now the oval shape, the oval shape. Uh-huh. Go on. Hmm. Okay, so p orbital. Hmm. Okay, S looks like this. It's like a circle. P orbital looks like infinity. It can be like this. If it is p, let's say it's px, can be like this. If it is py, it can be like this. Let's say pz. So the character of p orbital, which will determine characteristic of an atom, is directional. Okay. An atom with 5 protons, 6 neutrons, and with a charge of 3 as an atomic number of. They've even told us already atomic number is the number of protons, and you've been told 5 protons. So that's the answer. Almost the entire mass of the atom is concentrated in the. Now, mass is going to be in the nucleus, where I've got protons and neutrons. That's where the mass of an atom is concentrated, because the mass of a proton is 1, neutron is 1, electron is 1 over 1840. So the electron is way much lighter. All right. Next question. How many orbitals are completely filled with electrons in an atom of phosphorus in the ground state? So for you to be able to answer this, how many orbitals are completely filled with electrons, you need to know the atomic number of phosphorus. Okay, just that. And then you'll be able to determine. Let me just find out the atomic number of phosphorus. So the atomic number of phosphorus is 15. So when you are filling orbitals, you first fill the 1s orbital with 2 electrons, and then the 2s orbital with 2 electrons, and then the 2p orbital with 6 electrons. From 2p, then we go to the 3s with 2 electrons. How many have I used up so far? This is 12. I'm remaining with only 3. So from the 3p, so how do you fill the orbitals? You start with 1s, and then 2s, and then 2p, and then 3s. Okay, actually, yeah. And then here we have 3p, 3d, 4s, 4p, 4d, 4f. When you are filling these orbitals, you always start with 1s, and then you go to 2s, and then 2p, and then 3s. After 3s, and then you go to 3p, and then 4s. After 4s, then you go to 3d, and then 4p. That's how you fill these orbitals, in that order. So since I've ended with 3s, which one do you think will be the next orbital to fill? Anyone? What do you think would be the next orbital to fill? I've already written for you here. So all you are doing is you are just pointing what I've already written. So the next one after the 3s you are filling is the 3p. Now we have already used up 2 electrons, 4, 10, 12. From the 15 remaining was only 3. So put 3 here. So how many orbitals are completely filled up? You can see 1, 2, 3, 4. Okay. We have completely filled up 4 orbitals. But take note that a p orbital has got 3 other orbitals in it. So meaning that instead of counting just p as 1, we'll count them as 3. So this is going to be 1, 2, 3. Plus these 3, that makes 6. So that will be it. What is the total number of s electrons for chlorine with 17 electrons? 17 electrons, let's write the configuration. It's going to be 1s2, 2s2, 2p6, 3s2, and then 3p what? So we have used up 12 from the 17. We are remaining with 5. So 5 we'll put here. So what is the total number of s electrons? We have got 2 here, 2 here, 2 here. That makes them 6 s electrons. So that's the answer there. Number 13. How many orientations would a p orbital have in space? I've been talking about this. You can have 2py, 2px, 2pz. These are 3 orientations in space. How many valence electrons does an element with the atomic number of 11 possess? Valence electrons, write the configuration. That is going to be 2, 8, 1. The last electron in the outermost shell, that is 1. That's the number of valence electrons. How many valence electrons does the following atoms have? Does the following atom have? So the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And the question is how many valence electrons? Valence electrons are electrons in the outermost shell. Look at the shells. This is the first shell. N is equal to 1. This is the second shell. N is equal to 2. This is the third shell. N is equal to 3. This is the fourth shell. So the outermost shell is the fourth shell in this case, and it has got only 2 electrons. Water molecules are held together by dash in a water body. What holds water molecules? So let's say this is one water molecule, another water molecule. What do you think? What is going to hold these water molecules together? Any idea? So water molecules are held by hydrogen bonds. That is what holds them. That is going to be the answer. Identify the false statement. Water adheres to the surface of its container. This is a true statement. When water adheres to a container, that is known as adhesion. The attraction between unlike molecules. Water conducts electricity. Okay, I'm going to put a dot here. Water will actually do conduct electricity, yes. But then others will say it's not a conductor of electricity. That is because it is weakly ionized. Water can dissolve proteins. This is true because proteins have got parts which are polar, so they can dissolve. Water sticks to glass because of cohesive forces. Sticking to glass is not cohesion. Water and glass are two different molecules, so that is adhesion. Water molecules, water moves along blood vessels because of cohesion and adhesion. This is correct. Cohesion is one water molecule attract another water molecule. Adhesion is water will be attracted to the surface of the blood vessel. So the incorrect answer is 4 there. Water boils in lake and oceans. Water bodies in lake and oceans have constant surface temperature because constant temperature, you need to know the properties of water. One property of water is that water has got a high boiling point. Okay, it has got a high heat. Let me not even talk about boiling point. What we talk about is the high heat of vaporization, delta H of vaporization. It has got also high specific heat capacity. And this is one property. Second property. The third property is water can show cohesion and adhesion. The fourth property is the density for water. The fifth property is surface tension. Surface tension. You see they will write the gamma there. The sixth one I can talk about is capillary action or capillarity. So we need to know what these are and the importance. Starting with the first one, high heat of vaporization. For water to vaporize, to become a gas. Now vaporization is a change of state from liquid into a gas at room temperature. Okay, you are not changing really you are not heating something. It's different from boiling where you heat just at room temperature. Water can change from liquid into a gas, but for it to do that it takes in a lot of heat. And because it takes in a lot of heat in human beings and in dogs, that is going to, and in animals basically, that is going to be important in that by the time water is leaving the body and sweating as heat, as vapor, we are going to be cooled. So the first property is important in what we call the cooling effect. So we are cool. That's why dogs will pant like that. They are being cooled. High specific heat capacity. Heat capacity is the amount of is how much heat energy is going to be taken in by a compound for the temperature to change by 1 degree Celsius. So if water is at 25, for it to go at 26, it is going to take in a lot of heat. So just a small change in temperature, you take in a lot of heat. So this property is important in maintaining constant internal environment, and that is known as homeostasis. So the temperature will not change not until you take a lot of heat from the body. Okay, so this is necessary in maintaining a constant internal environment. Cohesion is one water molecule attracting another water molecule. So this is important in a lot of things. All the properties of water is because of cohesion. Hydrogen bonds is because of cohesion. Surface tension is because of cohesion. Everything about water, one water molecule attracts another water molecule as it moves because of cohesion. Adhesion, water can be attracted to other molecules, like for example to a glass cup or to our clothes, and this is going to be responsible for wetting of our clothes. Our clothes get wet because water can be attracted to them. Density, water is densest at 4 degrees Celsius. Above 4 degrees it is light, above below 4 degrees is light. So if you look at the graph for density, you see it like, let's say if this is 4 degrees Celsius, this is density this side. As you increase the temperature, the density of water is increasing. When you reach 4 degrees Celsius, it starts to drop again. You can see the maximum density is at 4. This enables water to act. 4 is the densest water, so it's going to be at the very bottom of the river. This is the important thing, that even when it is cold in cold season, you can have ice on top of water, which is at 0 degrees because it's light, and then hot water is down. So fish will be at the bottom in cold season. That's why I don't fish in cold season, because fish is down. Surface tension, this one is actually because of cohesion or hydrogen bonds. One water molecule is attracted to another water molecule. That forms like a film on water, such that an insect can step on top of the water and then it will not be able to sink. That's because of full surface tension. It's due to cohesion. Capillary action is where fluids are able to move up a tube without any external force. It's just because of cohesion and adhesion. So capillary action is because of cohesion and adhesion. So I've explained all the properties of water, so you should be able to know them and how they are applied. So this question, we can now even answer. We want to maintain a constant surface temperature. Water freezes at 4 degrees. That's not the reason for constant surface temperature. Hydrophobic interaction is not a reason. Water shrinks every degree. That's not a reason. Has a high specific heat capacity. Okay, high specific heat capacity. Yes. Has a high latent heat capacity. That's not a reason. Okay. So that is it. Latent heat is the hidden heat. It's the heat that you have to gain or lose to change the state. Maybe from liquid to gas, gas to solid, and everything like that. When oxygen combines with hydrogen to form water, here there are two lone pairs of unshared electrons. You can see these two electrons on oxygen. They are there, yes. Okay. There is one lone pair of unshared electrons. This is not true. It's not one. Ionic bonds are formed between oxygen and hydrogen. This is not true. It's covalent. Develops a positive charge. When water combines, there is no charge. Water will not have any charge. But the bonds, of course, are polar. Because oxygen is more electronegative, it's going to have a partial negative charge. It's going to be attracting electrons from hydrogen, which will remain with a partial positive. Same with this side. So oxygen has got two partial negative charges, while each hydrogen has got a partial positive charge. Covalent bonds are formed between hydrogen atoms. It's not hydrogen atoms. You can see it's between hydrogen and oxygen, not the two hydrogens. Then they don't form a bond. The bonds that are broken when water vaporizes. Any change of state that happens to water, what you break are hydrogen bonds. You're going to have another water molecule like this. It's attracted to another water molecule by hydrogen bonds. Okay, so it's hydrogen bonds which will be broken for any change of state to happen. Sucrose is a non-reducing sugar because the dash of its fructose ring and the dash of its glucose ring are not free. Now, when you are forming fructose, you are going to have sucrose and the fructose. Sorry, you are going to when you are forming sucrose, you are going to have fructose and glucose. Now, the fructose is a ketone. The functional group of fructose is at carbon number 2. And the functional group of glucose is at carbon number 1. So both functional groups are going to react, and when functional groups are not free, such a sugar is not going to be a reducing sugar. It's a non-reducing sugar. And fructose is the only non-reducing sugar which is a disaccharide. So it is C2 and C1. Okay, that's 2. Identify the asymmetric carbon atoms in the molecule below. Asymmetric also is called chiral. A chirocarbon is a carbon that is bonded to four different things. Four different things. You can see carbon number 5 has got 3 hydrogens, so it's not chiral, it's not asymmetric, it's symmetric. This carbon has got 2 hydrogens, so it is also not asymmetric. But this carbon here has got what? Has got OH, it has got H, it has got this big group, and then it has got this big group on top. So C3 is asymmetric. It's bonded to 4 different things. How about C2? Look at C2. It has got hydrogen, it has got OH, it has got this big group, it has got also this group. So C2 is also symmetric. So the answer is 2 and 3, which is option 5. Identify the sugars that does or do not have the empirical formula CH2O. Now CH2O is the empirical formula for monosaccharides, except deoxyribose. Why? Deoxyribose doesn't have an oxygen at carbon number 2. That's why we call it deoxy. So this one will not have that empirical formula. Lactose. Lactose will also not have. Why? Because it's not a monosaccharide, it's a disaccharide. Okay? So disaccharides, polysaccharides will not have this empirical formula. This empirical formula is for monosaccharides, except the deoxyribose. So the best option is 1 and 2. Carbon dash of glucose combined with carbon dash of the same glucose to form a pyranose ring. A pyranose. When you look at this, look at this. This is glucose. Please, when you are forming rings, you only use the D glucose. So this is your molecule. At the last carbon, you have got oxygen, and then it's bonded to a hydrogen. And then the last carbon also have got CH2OH. Okay, so this is carbon number 1. This is carbon number 6. So you are going to have 4 more carbons on the middle. 1, 2, 3, 4. So for glucose, D glucose, OH should be here, and then OH here, and then OH here, and then OH here. It makes like S if you follow the OH. Let me show you so that you just remember. It will make like this. You can see this S. So if I take this OH from here, I put it here. This will make a C. This changes, is no longer glucose, it's now fructose. They can give you those structures to identify, that's what I've mentioned. So the rest will be hydrogens. Every time you are forming a ring, it's always carbon number 1, not carbon number 1, forgive me. It's always the anomeric carbon. Anomeric carbon is a carbon containing the functional group. So anomeric carbon will always react with the second from last carbon. So here, this glucose has got 6 carbons, so second from last carbon will be carbon number 5. If this was a trio, second from last carbon will be carbon number 4. That's how you form. And fortunately for glucose, the carbon containing functional group is carbon number 1. So carbon number 1 will react with carbon number 5 to form a pyranose ring. This ring that you see like this is what we call a pyranose ring, like this. So the answer is 1 and 5, which is option 4. Identify the functional group in carbohydrates. Now carbohydrates have got what we call a carbonyl functional group. This carbonyl can either be this group here. This is carbonyl. It also has OH. Can you see? OH is hydroxyl. So these are the two functional groups. Now the carbonyl can either be at the end or on the mid. If it's at the end, it's known as an aldehyde. On the mid, it's known as a ketone. So it's C, carbonyl, and it's not carboxyl, it's carbonyl. So this is not true. Aldehyde and ketone. This is true. Aldehyde and ketone, alright? I've just said that the carbon can either be an aldehyde if it's at the end or ketone if it's on the middle. Hydroxy and amide, this is not true. Carbonyl and hydroxy, this is true. So the answer is 2 and 4 are correct. The cellulose microfibril are held together by dash between adjacent chains. Cellulose. Now in cellulose, we have got beta 2,4, 1,4 glycosidic bonds. So you have got molecules. One molecule is like this. I don't want to draw the actual molecule, how it looks. Another molecule is like this. These guys are attracted by hydrogen bond. Cellulose is found in the cell wall of plants. So it's hydrogen bonds. Okay. So not hydrophobic, sorry, I've taken another one. So it's hydrogen. Where is hydrogen? Option 2. How about glycosidic bonds? Glycosidic bonds will be able to hold each molecule of glucose. Okay? Each molecule. Each molecule. Let's say this is one glucose molecule. Connects with another glucose molecule. These two guys are held together by glycosidic bonds. And then another glucose molecule. Another glucose molecule. That will be the same. Now you're going to have another one. A glucose held to another, just like that. So what are we saying? These guys are held by what? Hydrogen bonds. How about glycosidic bonds? Can we not qualify that? So maybe you need to understand what microfibrils are. So when you're talking about microfibrils, you're basically talking about the arrange. So are you able to see these molecules that I've drawn like this? These are two different molecules. They are going to be attracted by what? Hydrogen bonds, right? Like that. And then this, if you get a lot of these, you put them together. So now they'll start appearing like this. They'll appear like bundles. If you get now a lot of this, you form something much bigger. These bundles like that form something bigger. So it's now called a macro fibres. Okay. So you actually also have glycosidic bonds. You're also going to have glycosidic bonds. Those are the ones which are forming the bonds. Let me pause a bit. I've been talking a lot. Is there any question? Is there any question? So which one would be the best answer to pick here? Please. This one chain alone is held by glycosidic bonds. To hold the chains here for you to be able to form a microfibril, you only have hydrophobic interaction. Sorry, hydrogen bonds. Okay. So cellulose microfibrils are going to be held by what? Hydrogen bonds. C3H8O3. I did mention this. This is not a carbohydrate. The carbohydrate is supposed to have the ratio 1 to 2 to 1. This one I've written down here is a carbohydrate. It's known, it is a triose. It's either dihydroxyacetone or glyceraldehyde. This one on top is glycerol. It's a lipid. So it's a lipid. Here, option 2. Beta fructose must 10 dash degrees in order to make the 1,2 glycosidic bond in sucrose. Anyone to try this one? How many degrees should the beta fructose tend to make 1,2 glycosidic bond in sucrose? Anyone? Okay. So we know how the molecule is formed. The molecule in sucrose. Sucrose is going to be okay. Let me ask maybe a very simple question. What makes up sucrose? What are the molecules that make up sucrose? I'm just from mentioning this one, please. Anyone? Yes, it's glucose and fructose. Just that. So when we are forming this guy, sucrose, you are going to have one molecule like this. This is going to be fructose, and then with the glucose is going to be like this. When these two guys bind, w- look at how it's going to be next. The this fructose, look at how it's going to look now. Can you notice how it has gone? So it was looking up, it's now looking down. This is how you form the bonds in this molecule. So what's the angle from up to down? From up to down. What's the angle here? Anyone to help me? It's a very hard question. What's the angle? You can even see this is a straight line. What's the angle of a straight line? It's 180 degrees. Identify the statement or statements that is or are a function or functions of carbohydrates. Carbohydrates are there for structural support. Yes, for example, cellulose. Immediate energy provision. Okay, yes, like glucose. Energy storage. Yes, like starch. Formation of nucleic acid. Yes, like pentoses. So the answer is all of the above. The helical structure of amylose is stabilized by amylose is like this. Okay, helix, an helix, just something that turns about itself. So it's going to have hydrogen bonds. Okay, hydrogen bonds. Inside the hydrogen bonds, you also have covalent bonds because between one glucose molecule and another glucose molecule, you need a covalent bond. And that covalent bond is known as a what? A glycosidic bond. So we can pick 1 and 4 correct. That is going to be the same with this question that I mentioned here. If they wanted us to also talk about the glycosidic, if they also wanted us to mention the bonds which are inside the molecule itself, we can pick 5 as the best option. But the microfibril is going to be held by hydrogen bonds. The only polysaccharide synthesized in the human body, amylopectin. This is a storage in plants. This is starch. Same with amylose. Glycogen is in human. This is the storage form of carbohydrate in animals. In human, it's found in the liver. State the constituent unit sugar for sucrose and maltose in any order. Now, sucrose is going to have, we know it's fructose and glucose, right? Maltose is going to have glucose and glucose. So these are the constituents of these three guys. So it's fructose and glucose. Okay. So galactose is not there. Fructose and glucose, this is true. Glucose and galactose, no. Mannose, no. Galactose and fructose, no. Identify the incorrect statements. Dihydroxyacetone is a triose sugar. This is true. Fatty acids and glycerol are products of hydrolysis or fats. Fatty acids and glycerol. This is true also. That is because look at this. When you have got glycerol, glycerol is like this. It has got hydrogen, 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 and then it has got OH, OH, OH. But here it can react with a fatty acid like that. That's a fatty acid, another one. That's a fatty acid, another one. That's a fatty acid. So what can happen is that when you react this molecule with water, it will be broken down into a fatty acid and glycerol. Because when you are forming this molecule, you actually release water. So that's why that option is correct. And then the next one, triglycerides. Triglyceride is an aldehyde. This is not true. Triglyceride is a lipid. Okay, this same molecule that I'm from rubbing here, that's what we call a triglyceride. It's not an aldehyde. Aldehydes, these guys are who? These guys are carbohydrates. Primary function of carbohydrate to supply a cell with energy. That's the function. Function carbon in fructose is found at carbon number 2. This is true. Fructose, the function group is at carbon number 2 because it's a ketone. The melting point of saturated fats can be changed by adding hydrogen. By adding hydrogen. Okay, when you add hydrogen to saturated, you know the meaning of saturated, you have got no double bond. There's actually nowhere you can add the hydrogen, but in case you add another carbon, you can change the melting point. So let me just put a dash there. Because of adding hydrogen, there's no way where you can add the hydrogen on a saturated fat. And saturated fats can be increased by the removal of hydrogen atoms. And saturated fats can be increased by the removal of hydrogen atoms. This is true. And saturated fat is a fat that has got a double bond. So when you remove an hydrogen atom, you are forming a double bond. Both saturated and unsaturated fats are the same. This is not true, they are different. Unsaturated fats are lower than those of saturated fats. So the melting point of unsaturated fats is lower. Unsaturated fats, they have got a double bonds. They are normally liquids. And the saturated are normally solid. So liquids have got a low melting point. Okay, this is true also. Unsaturated fats are higher than those of saturated fats. Let me look at this. Unsaturated fats, the melting point of unsaturated are higher. So this is not true. So we should be able to review the one option on top. The melting point of both saturated fats and unsaturated fats are the same. they are not the same, they're actually different. So want what is true. This is not true. So which one have I been taking? I've been taking what's false, what's true. And so the unsaturated fats are higher than those of saturated. What have I said about this one? Unsaturated fats are higher. I've said that the unsaturated are solids, are liquids. Saturated don't form any bonds, they are solids. So solids have got a high melting point, isn't it? So this option is false. Okay, so the one which is supposed to be true is this one. So meaning that the first ones on top should also be incorrect. Saturated fats can be changed by adding hydrogen. So how can you disqualify this one? You can't add an hydrogen to saturated fats. Why? Because they are already reacted fully. You don't have anywhere to add hydrogen. It's saturated. It's enough. Option 2, unsaturated fats can be increased by the removal of hydrogen atoms. If you remove hydrogen atoms from here, just that you can make another bond, but that will not increase the unsaturated molecules or the unsaturated fats. You can make another double bond, but you are not increasing the unsaturated fats. So in biology, when you find an answer, don't be quick to conclude that it's the answer. Look at the other options because you might just find out that what you chose was not actually the right one. Lipids are esters of fats and oils. This is true. Polymers of fats and glycerol. Now, lipids are not polymers. All the biomolecules that we talked about are polymers, except lipids. Polymers are molecules which are formed from monomers. We don't have monomers for lipids. Esters of fatty acids and actually this is the so this one, esters of fats and oils. Lipids are fats and oils, not esters. Okay, they're just fats and oils. They are esters of fatty acids and alcohol. This is the answer. Okay. Of course, they are not the same as triglycerides. Lipids are not the same as triglycerides. Triglycerides are going to be just an example of a lipid. So we can say we want to pick only the best answer. What the definition of a lipid is. So it's an ester of a fatty acid and alcohol. Lipids are partially soluble in water because they are amphoteric. Let me put a dot, and neutral. Neutral is not the reason for being soluble. Hydrophilic is not the reason for solubility. They do not have a charge, that's not a reason. Have a hydrophobic tail, that's not a reason. So they are amphoteric. They have got one end that is hydrophobic, another end that is hydrophilic. Triglycerides, which are made up of dash, are liquids at room temperature. As I said, liquids are unsaturated hydrocarbon chains. Identify the molecules which are highly reduced. Highly reduced means that they have got a lot of hydrogens. So if you compare these three, mono, di, poly, poly is going to be having a lot of hydrogens. Okay. And then triglycerides also have got a lot of hydrogens. The best we can actually even qualify is triglycerides. Next year, for some of you will be coming to Ridge where you learn this in biochemistry. Why is it that lipids form more energy than carbohydrates? Because they are highly reduced. They have got a lot of hydrogen atoms. Identify the lipid that has a charged component. Identify the lipid that has got a charged component. So, lipid with a charged component is a phospholipid. A phospholipid has got a phosphate in it, and that phosphate is negatively charged. That's the uncharged component. Are you still able to see my screen? Okay, just give me a moment. Are you able to see my screen now? Okay. Now question 40. An Easter bond is a linkage. When you're talking about Easter bond, okay, remember we've said that a carbohydrate, sorry, a lipid is an ester of a fatty acid. The function group of a fatty acid is carbon, double bonded to oxygen. It's an acid and OH. And then with an alcohol, if lipid is an ester of a fatty acid and an alcohol has got OH as a functional group. So when these two guys react, that to form an ester. So OH group of carboxylic acid and OH group of an alcohol. This will be able to react with this to form an ester. That's true. So double bond of carboxylic acid with an alcohol. No, it's not this one which will react. OH group of fatty acids and C of lipid. No. Okay. No. So these other questions they're on nucleic acids, but then you guys are not having nucleic acids in your test. For the sake of the paper, let me just answer this question because you have to revise it later on as you'll be writing the exam. So what you can do is, since we've already done what is coming in your test, you can just disconnect and then I can continue to answer these, which are these you'll write them later on. You'll be able to revise them for your exam. Okay? Nucleic acids are polymers of monomers called pentose sugars. Now, nucleic acids are not polymers of pentose sugars are not the monomers of nucleic acids. They're going to be made from nucleotides, so these are not true. Polymers of amino acids also no. Storage molecules for inheritance characteristics. This can be true depending with which type of nucleic acid we're talking about. Polymers of monomers called nitrogenous bases is not also. Nitrogenous bases, pentose sugars, and the phosphate group. Those are just components. They are not the monomers. Synthesized from combination of two types of nucleotides. So this is true. Okay, this is true. Now option 3, storage macromolecules for inheritance characteristics. The storage is only because we've got two types of nucleic acids, DNA and RNA. DNA will be used for storage, but not RNA. So this option is too generalized. That's why the best we can put is option 5. Identify the molecule which is part of DNA. Now, DNA, we are going to have this. This is a pentose sugar, a phosphate group, and a nitrogenous base. These are three things. This is what makes up our DNA. But the nitrogenous bases here, we have got adenine, which forms two bonds with thymine. And then we have got cytosine, which forms three bonds with guanosine. This is what you find in DNA. In RNA, instead of having A pairing up with T, we don't have thymine, we have got uracil, so it will be A with uracil. Okay, so I define the molecule which is part of DNA, deoxyribose, and also the sugar. The sugar that you use, RNA you use ribose, DNA you use deoxyribose. So yes, deoxyribose, this is true, not deoxyribulose. This is not true, not ribose, not glucose. Uracil is not found in DNA, it's only found in RNA. RNA is important to biological systems because it is only composed of carbon, hydrogen, and oxygen. Is that the reason as to why it's important? No. It's made up of deoxyribonucleotides. It's actually not made up of deoxyribonucleotides. It's made up of ribonucleotides. It's made up of RNA, not D. I mean, it's made up of ribose, not deoxyribose. Forms a complex double helical structure. It's not double helical, it's single helix. DNA is going to be like this, but RNA is just going to be like this. It is single stranded, contains ribose. This is true, it does contain ribose. Plays a role in protein synthesis. This is true. So the question is biological importance. It's not because it contains a ribose sugar. The importance is that you can convert RNA into proteins. That's a biological importance. So it's option 5. A molecule of DNA is made up of repeating units of. Now, DNA is going to have nucleotides. Nucleotides is a phosphate group, a pentosugar sugar, and a base. You're going to have another one, phosphate group, pentosugar sugar, and a base. So this is one nucleotide, this is the second nucleotide, another one, another one, another. You're also going to have other ones this side, forming bonds here. Okay, so it's nucleotides. If you remove a phosphate, you have converted the nucleotides into a nucleoside. State the difference between DNA and RNA. Thymine in DNA versus uracil in RNA. This is true. That's one difference. Deoxyribosugar in RNA. No, deoxyribosugar is not in RNA, it's in DNA. That's why I call it DNA because deoxy. Phosphodiester bonds are found in O. Okay. And also the hydrogen bonds are found in O. RNA double-stranded versus DNA single-stranded. This is the opposite. DNA is the one which is double-stranded. RNA is single-stranded. Adenine is found in RNA. Adenine is found in O. Identify the correct statement about nucleic acids. They are only composed of carbon, hydrogen, oxygen, and sulfur. You want what is what? What's the question? Identify the correct. They are composed of carbon, hydrogen. Okay. They are composed. So nucleic acids are made up of a phosphate, then a pentose sugar, nitrogenous base. So the sugar only contains carbon, hydrogen, and oxygen. So you can make carbon, hydrogen, oxygen. The base contains nitrogen. And then we have got phosphorus here. So this one can't be true because of the phosphorus. This one because of the chlorine. This one is true, nitrogen and phosphorus. Okay. And then this one composed of carbon, hydrogen, oxygen, nucleotides, and sulfur. This is also true. The nucleotide. Now, the all of these molecules with the nucleotide, so this is going to be not correct. This one is not going to be correct because of sodium, so the best option is 3 there. Identify the type of reaction that joins components of DNA together. So, when you want to join a phosphate with a pentose sugar, the bond you form there is known as a phosphate ester bond. Then the bond between a nitrogenous base and our sugar, this is known as any glycosidic bond. This reaction is supposed to release water, so it's hydrolysis reaction. Identify the correct statement. Adenine is pyrimide. So when you talk about pyrimidines and purines, so you have got purine, we use pure as gold. Purine, you have got adenine and guanine. And then pyrimidine, you have got UTC, put C. The P from pyridine, put C. So adenine is a pyrimidine, that is not correct. Uracil is purine, that's also not correct. Guanine is pyrimidine, that is correct. Thymine is pyrimidine, that is also correct. You can see that thymine is a pyrimidine. And then C, cytosine is purine nitrogenous base. This is not correct. Okay. Now, we can't have two answers for the same question. Guanine is a pyrimidine nitrogenous base. Thymine is a pyrimidine nitrogenous base. Okay, for guanine is not a pyrimidine. You can see where it is. Guanine is a purine. So the answer is only option 4. We'll end at question 50. In a DNA molecule, guanine and cytosine bases are held together by. Now, guanine and cytosine are going to have 3 hydrogen bonds. Adenine and thymine are going to have 2 hydrogen bonds. So it is a 3 hydrogen bonds. Identify the correct statement. Nucleotides are made of hexose sugar. They are not made up of hexose sugar. Just this makes it wrong. It's pentyl sugar. Nucleotides are composed of nitrogenous base attached to a sugar only. This is not true. So nucleotide is a phosphate attached to a pentose sugar and then a nitro base. So this is not true. Nucleotides are made of pentose sugar, nitrogenous base, and a phosphate. This is correct. Nucleotides are made of sugar and phosphate groups. That's not true. Nucleotides are made of triose sugar. It's not a triose sugar, it's a pentose sugar. So the best option is option 3.